So, just a quick introduction, and I'm really excited, I'm jazzed to be here tonight because I get to talk about grid deflection, energy efficiency, renewable energy, and really the impact this is having with utility companies. And what I really enjoy about this is an opportunity tonight to highlight some of the products and services, the cutting edge technologies that our company, Applied Energy, installs. So real quick about myself, I'm president of Applied Energy Innovations. We are a energy efficiency and renewable energy contractor located in South Minneapolis. Some would say we're kind of a boutique contractor specializing in high-end technologies. We are electrical, mechanical, general contractor. We do weatherization. We do a variety of extreme green energy products that have been highlighted in the press and the media, taking a particular house, tearing roofs off, putting in new insulation, two-part foam, putting in solar systems, putting in EV car chargers, heat pumps. People do this. It's amazing. It's amazing how we can take a home, an existing home, and take new home technologies such as passive homes and make them net zero. Also co-founder and president of Minnesota Community Solar, president of Minnesota Solar Energy Industry Association, which if you're not aware of is the advocacy and political arm that represents the trade group of installers, the solar industry here in Minnesota. So we're doing a lot of work at the Capitol. We've been involved heavily with the legislation around the Clean Energy Jobs Act that passed in 2013. And we have our huge big conference coming up in November. So I encourage you guys to check out MNCA, check out our website. We have our second annual conference coming up. And as Doug had mentioned, a former board member with MRES. A little bit about AEI, as I was explaining, a renewable and energy efficiency contractor serving residential and commercial properties. AEI retrofits and installations have removed over 6 million dirty BTUs off the grid while adding hundreds of kWs of clean energy back into the grid through our renewable energy systems. Started out of a Minneapolis garage. Company has outgrown 3 offices to serve over 600 customers. 90% of our business is within 5 miles of our office, and 80% of our business is repeat customers. I'm really proud of that. That garage was actually my garage back in 2010 in January. It was a very, very cold office to start out of, but I had just gotten off of a year and a half of unemployment. My prior background, my life is 18 years in the commercial industrial trades, and through that I worked for companies such as Egan Companies, and we did deep energy retrofits for school districts, for hospitals, for office buildings. And so I was able to take that 18 years of commercial experience in energy efficiency, deep energy retrofits, and really couple that over the next couple of years with renewable energy. So I'm excited tonight because really this is an opportunity, once I got bored with renewable energy, was to take our company to the next level and really start pushing the technologies. So we're going to talk about some of these technologies and how they're impacting the grid, and really talk about the science behind some of them, and really looking at what are the numbers and what are the results. So I've got a couple of brief case studies that we'll walk through. Feel free, you can ask questions as we go. I've got about 20 slides that we're going to power through here. And Doug, how long do we have? Or do I have? 7? All right. And I also see a set of clients in the room of ours, Dave and Nancy Moe. Thank you for being here. I really look at the clients and our customers as leaders within the community that have made that purposeful decision to invest their dollars back in their properties to make a difference. And we couldn't do it as a company without leaders in the communities that emulate the need for change in how we produce energy, how we conserve energy. We need those leaders in the community. So thank you guys for that commitment. One thing I need to take a quick step back, and this is one of my favorite slides. I took this from a presentation Jan Hubbard put together for MRES several years ago, but this really sums up what's going on. If you're familiar with the food pyramid many years ago, this is very similar to the energy pyramid. Starting out at the bottom, talking about understanding where and how our energy comes from, talking about conservation, low cost, no cost changes that we can make in our house. Whether it's changing out a thermostat, whether it's doing insulation,
whether it's unplugging portable devices. All of these things, when you start to build them up, have a tremendous impact on both commercial and residential properties. Moving into lighting, CFLs, fixtures, LEDs, doing air sealing, appliances, insulation and ventilation, water heating and cooling windows, renewable options. This sums up exactly what we do as a company and the science that we install on individuals' properties. Now, I have to preface that with saying it's important, while the new technologies are emerging, that we choose those technologies carefully. Number one thing we don't want to do with a property owner's property is play Frankenstein and experiment with products or services that don't work. And I'm very fortunate in 18 years in the commercial side to have experience and see some of these technologies roll out and see how they've evolved. But I think it's very important that we need to choose manufacturers that have been around. We need to choose manufacturers that are going to stand behind their warranties. They're going to stand behind their products. And I've also been a part of that process, even with some of the newer technologies that we install. I've seen some of these companies actually go bankrupt and cause some pretty big problems in the supply chain, the consumer chain, and the warranty chain on some of these technologies. So that's something that I think is very critical, very important when we think about these technologies that are installed in your house or your commercial business. So let's talk about what is grid defection. Define grid defection. According to American Scientific, the industry name for cutting the wire between homes and power lines is grid defection. And it's controversial because there is a broad disagreement about whether it's both possible and sensible. Now, many years ago, Al Gore got up, made some pretty strong statements about 3-4 years ago about individuals being able to cut that utility line. And there's been a lot of challenges and obstacles for consumers that want to get their properties, especially with renewable energy, want to get those renewable energy systems connected to the grid. A lot of barriers, a lot of challenges, mostly in policy and often in money. We look at the Southwest, for example, Arizona utilities. They have, I believe, right now a $60 a month fee if you have solar to interconnect it with their grid. So you can actually Google any number of stories about the challenges that we as Americans in our land of the free have installing energy systems with our own dollars on our homes and trying to get those interconnected with our utility companies. I'm going to take this opportunity because we're talking about utility companies, and I'm going to put my MNCEA president hat on, and I'm going to tell you my statement about Xcel Energy. We have the opportunity to upward manage Xcel to be the best utility company in North America. And how do we do that? We do that through good public policy. So some of the things we're going to talk about tonight: technologies leading the way, grid parity, solar PV and thermal systems, solar hot water systems, electric and thermal, hot water and heat pumps and ground source heat pumps, battery storage, the Tesla battery, ECM DC motors and variable frequency drive, LED lighting retrofits, passive house, and LEED platinum buildings. So how many know all these acronyms? Feel pretty good about it? Good. Let's jump into grid parity. A 2014 Rocky Mountain Institute report on grid defection suggested that by 2020, in some parts of the U.S., especially Hawaii, California, and New York, parts of the coast, and reliability of a home or business fully powered using a self-contained solar, photovoltaic, and battery system is quickly approaching grid parity. Grid parity is when the cost and reliability of that solar panel system is about the same as that of buying electricity like most people do today from their utility company. Let's talk about the changing dynamics in renewable energy, solar PV and thermal systems. You're going to see as I put this slideshow presentation together, I had the opportunity, very fortunate, to throw a lot of our own projects. You're going to see a lot of our own project pictures that are in these. Solar PV watt density, talking about the efficiencies and the watt density that's occurred just in the last 5 years. In 2010, we installed the most advanced Canadian solar panel that we could. That was our first system we installed. It was a whopping 210 watts. Now, we thought that was pretty exciting. Right now, the same footprint with higher efficiencies and higher watt density is pushing 300 watts. So in 5 years, we've gone from a 210 watt module to a 300 watt module with the same footprint. Add that up on a 10 panel system and it outperforms at 900 watts, almost a full kilowatt. So that's a big difference. And what's amazing is when we installed this system back in 2010, that system went in for close to $7 a watt. And for those of you that are savvy, understand that a lot of traditional solar systems right now, not the MIMs, but they're going in at anywhere from $4 a watt to $4.50 a watt. So what we've done in the industry is we've increased our watt density in the same footprint, and we've dropped our costs substantially. Let's talk about solar thermal, high-performance systems. More high-performance systems are coming out in the solar thermal and specifically hydronic, hot water heating. Systems such as the Bosch Baderis, better construction, sealed units, selective coatings, HARP design of their hot water, the copper piping inside of it. I know this system in particular, not the picture here, but Dave and Nancy Moe have a Bosch Baderis system on their roof. The new technologies for solar hot water systems, electric and thermal. Who's here has heard of the Sun Bandit system? So Sun Bandit is pushing technologies, creating hot water by using a very specific, their proprietary inverter and using resistant electric heat to heat hot water with approximately 3 solar panels. What's unique about this is the 3 solar panels, it's not a grid-tied system. So this system's going to heat water. Now it does have an electric backup to the grid. So let's say you have extended days, maybe you've got 2-3 days of overcast, or maybe it's in the winter where you don't have sun. You have the opportunity with technologies now where people can actually have a standalone system heating water, whether it's both solar thermal or solar PV, where they don't have to necessarily be dependent on having electricity from the grid heating their hot water. Now, as many of you probably know, the second biggest energy consumer in a house is doing what? Heating hot water, correct. The first biggest consumer in your house is the energy used to condition your air, whether it's heating or cooling. And we're going to talk about some of those technologies coming up too. The Bosch Baderis solar thermal system. Here's a quick example. This is a 4-panel system that was installed in Powderhorn neighborhood. This system has a backup HTP 96% efficient boiler. Here's what's exciting about this particular install. This was a duplex. And in this duplex, he had 2 gravity boilers. Now imagine the efficiency on gravity boilers. And he had 2 atmospheric vented hot water heaters serving up and down the duplex. And it was an owner-occupied duplex. What we did is we went in, took out all of the atmosphere, all of the gas-powered equipment, and we replaced it with a 210-gallon hot water storage tank. We did that with a solar thermal system with the Bosch Baderis. We did a backup with the HTP boiler. The boiler's doing both the upstairs and downstairs heating now. So now we've taken 4 gas-fired appliances off of his meters, got them down to 1 that's 96% efficient, and that will do the backup on the solar thermal system when the units need hot water. Both units are run off of this 210-gallon tank. Why did we do a 210-gallon tank? Because we really wanted to maximize the duration of that hot water. Think of it like a battery. What we did was we went one step further. We supercharged that tank because we know with the Bosch Baderis panels, we can get temperatures up to 400 degrees. Now, we don't need 400-degree hot water, but we can supercharge that tank up to its rated listing of 180 degrees. What that means is we put a thermostatic mixing valve on top of the tank, so the water that comes out is never hotter than 120 degrees. But the water in the tank is 160 degrees, which means I can get that entire household, that duplex, I can get them 3 days without any sun, enough hot water for them to enjoy baths, showers, dishwashing, laundry, you name it. So again, it's the use of technologies, and this particular customer, like a lot of customers that come to us, said, I want to get as far away from natural gas as I can. And so we listened to that, and we sized and we put together a system. Now, the next question is, how efficient are these systems really making hot water in the winter, right? So, I'll give you an example. This is January 1st. I don't know if you can see it right here, but the date is January 1st, 2013, and it is 10 o'clock in the morning. Don't ask me why I'm at my customer's house on New Year's Day, but I thought this was pretty cool because it was cold out. Went over and took a look. It is 5 degrees out at 10 o'clock in the morning. The sun is just coming up. This little dot right here is the thermistor in the thermistor well on his hot water panel system. It is producing water, hot water, at 110 degrees at 10 o'clock in the morning, and it's 5 degrees outside. So this is my phone I'm holding here. That is over 100 degree temperature rise at 10 o'clock in the morning. That's pretty amazing. That's pretty impressive. The picture down here is exactly 1 minute later. I've now moved the sensor. You can see the sensor reflects the panel up here on the roof. I've now moved the sensor to the top of the tank. Because of stratification, hot water collects at the top of that tank. That's where we want to draw that hot water from. At 10 o'clock in the morning on January 1st at 5 degrees outside, he has 123 degree hot water ready to go out of his tap. So again, looking at these technologies, looking at what are the impacts these have in terms of our local utility companies, what are these consumers doing withdrawing their energy reliance from their utility, their relationship. Hot water and heat pumps. Love this technology. There's a great story behind this. So is anyone familiar with hot water heat pumps? House heat pumps. Yep, we're going to talk about that too. So we had a client in Longfellow neighborhood. We installed I think it was a 7 kW size solar system on their garage. Bruce and Aggie, and they had an old water heater that was going out. About 2 years after we installed the solar system, they came to us and said, hey, we really want to get rid of this water heater, but we really don't want to be reliant on natural gas. And so Bruce brought a technology to me that was actually new to me about hot water heat pumps. And it took him about a month of about every 3 days we were having conversations, and I kept telling Bruce, this is ridiculous. Why do we want to spend electricity that you're generating to heat hot water? It doesn't make sense. I don't get it. Electric resistant heat, while it's very efficient, it's not very efficient when you're using your solar PV system. But he said, Dustin, look at the math, do the numbers. The system that we installed, it cost their household, 3 people in the household, less than $100 a year to heat their hot water. And actually, they're doing it for free because they're getting it from their solar PV system. That was a learned lesson for me, but I had to go through, do the math, look at the numbers, look at the energy efficiency, and understand how this technology worked. On the right here, we've got a system. This is the GE GeoSpring. Installed that 3 years ago. This is their 2nd or 3rd generation. I believe they now are on their 6th generation heat pump water heater. How does a heat pump water heater work? Well, real quickly, what we're doing is we're taking indoor ambient air temperature from a room. We're putting that into a process of refrigeration, compression and refrigeration. And we're then heating that water with the ambient air. What's coming out is cool, cold air. And what did Bruce really like about this? He had a damp, wet basement. He now has a dehumidifier in his basement because he has an open space, large enough open space where this heat pump water heater is taking that air and conditioning it. Now, a lot of people are saying, okay, well, heat pump water heaters, I've done the research, they just don't work in cold climates, right? Wrong. Products out there now, such as AirTap, is the only heat pump water heater brand that meets stringent cold climate performance ratings such as those defined by the Northwest Energy Efficiency Alliance Tier 2 Standards program. AirGenerate, and that's the name of their product, have finished first in the hot water segment of Department of Energy's biannual solar decathlon competition 3 times in a row. Whereas most heat pump water heaters switch to electric resistance mode in cooler ambient temperatures, thereby giving up efficiency for several months in the year, such as the winter. AirTap heat pump water heaters have the capability to operate the heat pump even in sub-freezing temperatures. The impact is far-reaching. What they've actually been able to do with their technology is take a heat pump water heater, and they've got a duct system on here now. We can actually decide, hey, we can duct this system in terms of where we want to get the hot air from. Maybe we don't want to pull it from the basement. Maybe there's a warmer place in the house where we know up near a ceiling we can continue to pull that hot air. And maybe there's also an opportunity as it discharges that cooler, drier air. How can we use that in the property? We can discharge that air now. It's got a 6-inch duct on it. We can put that into different parts of the house. Pretty cool technologies. Ground source heat pumps, not going to cover too much on that because I think a lot of people are familiar with the technology behind it. Air-to-air heat pumps. Who's familiar with air-to-air heat pumps? Very good. So air-to-air heat pumps have made incredible strides in the last couple of years. And coming from a mechanical background, we installed commercially air-to-air heat pumps. A lot of communication, telecom facilities, air-to-air heat pumps. We used those. They were very good when we went into Bloomington School District when they started converting their custodial closets to telecommunications with their servers. They needed to get that heat out of there. So air-to-air heat pumps, pretty much, they used to primarily do air conditioning, but now the industry pretty much has made this heat pump do both heating and cooling. These 2 Mitsubishi units, can I see a show of hands? Who went out to the solar tour last weekend? Very good. Whose property was on the solar tour? Awesome. Very good. So this is the Peacefield Farms Passive House. If anyone made the long drive up to Stanfield, Minnesota, amazing, amazing products and technology used in this house. So these are 2 Mitsubishi OneTon heat pumps and air conditioners. And these are going to do heating the house down to -7 degrees. Is it negative 17 degrees? That's pretty amazing to extract energy at -17 degrees to create heat. And they're doing it very, very efficiently. How efficient? These 2 units here were rated at 33 SEER. So SEER is an acronym for Seasonal Energy Efficiency Rating, and it's a way of how they rate the efficiency of HVAC mechanical equipment. So these have a 33 SEER energy rating, and these units were pretty cool because if you're familiar with heat pumps, they have an outdoor unit. You think of this as your ductless heating and air conditioner. These units have indoor head units, and they've gotten the technology now to the point where we've got the head unit mounted up in two portions of the house. One is a bedroom, one is a very large second floor loft that they have. They now have these little rotating eyes at the bottom of them that sense individuals or people in the room, and if people walk away, it'll go into a default mode and it'll actually drop itself. Let's say if you're in a heating mode, it'll drop itself about anywhere from 5 to 7 degrees. Or let's say you're in a cooling mode and it doesn't need to keep constantly cooling. What it'll do is it'll raise the temperature so it doesn't have to work so hard. Now, what's unique about these technologies is a DC variable speed inverter compressor. I'm going to say it again, DC variable speed inverter compressor. What does that mean? Well, it means that what we all grew up with many years ago when we think about our air conditioning system or our heating system was a single stage on-off device, okay? I got a forced air furnace in my house, and years ago, lived in a house in South Minneapolis, big windows, had a couch right next to the window, and on very, very cold days, you were just waiting for the thermostat to kick in. I don't know if any of you have experienced that, but you were waiting for the thermostat to kick in for the cycle to jump on. And in our situation, it was a 100,000 BTU furnace. Now, I needed that in the coldest of winters, but I didn't need it in the shoulder seasons. It might be 40 degrees outside. I don't need 100,000 BTUs of heating. What I need is just a portion of that. And so with the new technologies coming on, the variable speed scroll compressors, is they're ramping up and down constantly based on load. They're also moving twice the amount of air. We're going to talk a little bit more about some more of the ECM DC motor technologies. Again, applications such as this project, Peacefield Farms, also have, I believe it's a 10 kilowatt array on site. They haven't had to use energy from the grid, I think, since they were commissioned. So this, in conjunction with their Steffers, their Steps brick heaters, this house came in, I think it's about 2,300 square feet. The BTU calc load came in at 15,000 BTU. A standard home is about 75 to 80,000 BTU for a house this size. This home came in with a calc load at 15,000 BTU. So these two heat pumps, along with the Steps brick heaters, do an amazing job to condition this property. Yes?
I have a quick question. So I have a
Fujitsu. Yep.
Dr. Kuhn's split heating air conditioning system. I don't use it if it's below 35 to heat. It just seems problematic.
Sure. Correct.
But you're saying you can use this when it's zero? I thought you said.
You can use this below zero to create heat. So for example, this application, they did not want to have a propane tank, and they did not want, they're far enough out where they don't have connection to natural gas. So their only connection they have is to electricity. So to generate heat, they have two choices: electric resistance heat or doing heat pumps of some sort. So in this application, it was a great fit. You also have split systems, commercial and residential split systems, where you have an outdoor unit, and unfortunately heat pumps, if you've seen them, they're about the size of a Volkswagen car. They're pretty big because they're using a lot of mass to grab that ambient air temperature to help do cooling and help do heating. Question in the back.
So the new systems that he's talking about, actually they're better than the Fujitsu, because we're building a house right now, we're putting in a Mitsubishi, and they're rated at the efficiency down to -5. But one of the issues, we're doing it because our house, I ran all the numbers, and it's going to only take, only needs 6,000 BTU to heat it. But because of the city codes and everything, he has to put in a 28,000 BTU heat pump. We have to have backup systems.
That's correct. Yep.
So the system isn't more expensive, and this is a small house.
Mm-hmm.
The system isn't more expensive because of what code requires.
Yep. So
And the new technologies, there are not new technologies in Asia.
that's correct.
So, that's what needs to change more than anything.
Yeah, city requirements under code right now does not view these technologies as a primary heat source. So they are going to require either a gas-fired or electric backup primary system. Whether you decide to use that primary system or not, right now in Minneapolis and St. Paul, code requirements do not qualify these as a primary heat source. So good point.
You know what, they can be primary, you have to have backup though.
Correct.
So you can stay to this primary as long as there is a backup.
That's correct. And again, you can have your backup primary, or you can have your backup system. You may or may not ever use it, depending on how your house is built. So let's think about this. Talking about air conditioning systems. How many of you have walked out to your air conditioner, put your hand over the AC unit, and it's spitting out all that heat in the summer? Okay? One of the things that I learned many, many years ago back in my apprenticeship program, they always taught us apprentices that AC system inside the house is a heat picker-upper, and that unit outside is a heat giver-awayer. We're not actually inserting cool energy into the house. We're removing the presence of heat in the airstream at the evaporator, and we're rejecting that heat outside. So that brings about a whole new set of technologies, what's called waste heat. Commercial properties, residential properties have a tremendous amount of waste heat. Depending on the industry or the business sector you're in, if you're in retail, if you're in the food industry, your freezers, your refrigeration cases are taking a ton of energy and they're rejecting that heat. Here's another example. An AC system heat pump for pools. Waste heat recovery. Provides free pool heating by recycling the waste heat that your air conditioner throws out. Here's an example where, as a refrigeration mechanical contractor, we're going to tie into the refrigeration lines of your property. In the summer, you're taking refrigerant, 410 or R22, through the process of condensing. You're taking that energy from inside the house, that heat, and you're throwing it outside. What we're going to do is we're going to intersect those refrigeration lines, and we're going to put them through a process that takes that heat and allows us to put the heat into the pool. In the process, the FPH increases the efficiency of your air conditioner, saving up to 40% on your electricity costs for indoor cooling. How's that? Well, it's happening because your compressor, condenser, is working less. Question?
Can you put that in your water heater instead?
Yes, there are technologies you can put this in your water heater too.
Yep.
Extend your swimming season to match your air conditioning season with zero pool heating cost. The FPH converts your standard AC into a water source geothermal type system, saving up to 40% on air conditioning costs. Automatic programmable thermostat controller monitors the pool temperature and activates the pool pump heat recovery when heat is needed to maintain the desired pool temperature. Operates day or night, rain or shine, only 6 to 8 hours per day of normal AC operation can heat a standard home pool. Now, I'm going to challenge that a little bit in our northern climate. Definitely in the southern climate, United States, where they're running air conditioners almost constantly in the summer months, you can get by with heating your pool with a system like this. You think the utility company likes that? Heat pumps, ground source heat pumps. So on the topic of heat pumps, let's take the heat pump and go to the next level with it. Let's make it a solar-powered heat pump. Now think about that concept. I've got all this sun in Minnesota, and I can power my air conditioning and my heating system up to 90% when the sun is shining. So I'm literally spending pennies a day to do my heating and cooling. Now, the technologies as they are out there are up to 1 ton. So this is going to do anywhere from about a 700 square feet to maybe 900 square foot space. You know, think of it as kind of your zone heating. This particular install we did in Lakeville, Harley here had a very large open living room. And that open living room was shared with his kitchen. And he also had a nice big ceiling fan in the middle of that living room. So we had a great space to install the head unit, and we had a great space for the outdoor unit right below it. So now what Harley is doing is he's running, every time the sun is out, he's running his system 90% off of the sun. What's unique about this too, that the utility company probably does or doesn't know, is that again, this is not necessarily an energy producing grid tied system. If we look here, he's got 3 solar panels. We have DC, direct current. And why does our heat pump like DC? Because it's a DC inverter variable speed scroll compressor. It loves DC power. It's going to take DC power straight from the panels, and it's going to suck it up all day long. Goes to our outdoor unit. We have our indoor unit right here, our head unit, and whenever we need backup AC voltage, it's going to draw it right from our electrical panel. So outside here, we have a DC disconnect from our solar system. We have a backup AC source for cloudy days, or let's say it's a hot, humid night and he wants to run his system. but he doesn't want to run the whole house air conditioner. Here's a solution. Think the utility company likes that? Pennies a day doing his heating and cooling. Let's look at another example. Solar thermal heat pumps for home or office use. The system will cool an area for pennies with 90% or more of the energy coming from sunlight. In addition to cooling, this particular model, the one you just saw, AC DC 12B solar heat pump will provide solar powered heating operating all the way down to an outside ambient temperature of 5 degrees. Let's talk about batteries, storage. Now, there's a whole lot I could talk about batteries, but the Tesla power pack that's coming out, the Powerwall, I believe is really going to be a big game changer. Reason why is because they took something that was so complicated at some point and they made it so easy. Battery backup systems, our company, we've done a few of them, just hundreds of different parts. The storage cabinet, the batteries, the charge controller, the transfer switch, all of these things, the monitoring of the batteries. It just was amazing when you look at kind of the science that it goes in to build and to put together a battery backup system. What do we like about this? Nice, simple. Powerwall comes in a 10 kilowatt hour weekly cycle and 7 kilowatt hour daily cycle models. Both are guaranteed for 10 years and are sufficient to power most homes during peak evening hours. Multiple batteries may be installed together for homes with greater energy need, up to 90 kilowatt hour total for the 10 kilowatt hour battery and 63 kilowatt hour total for the 7 kilowatt hour battery. You think the utility company likes these? All right, let's move on to ECM DC Variable Motors and Variable Freak Drive Motors. So in the commercial world, I was very fortunate and privileged to watch the evolution of what we call variable freak drive. Variable freak drive, think of it basically as a large commercial motor that instead of having a fixed speed, running at whatever RPM on and off, we can now match that fan motor RPM with the desired load required for heating and cooling. So again, typically another commercial application, when we installed the first variable freak drives with large commercial HVAC equipment, these units came into us and they were almost like the size of 4 or 5 lockers from floor to ceiling. The amount of electrical components in there and the circuitry required to run these variable freak drives. I now see systems that are running what I call fart fans, basically exhaust fans in bathrooms, commercial applications. I now see variable freak drives running rooftop fans that are about as big as an electrical box. It's amazing in the fact that they've taken the technology that used to be storage lockers in size and running very, very large electric horsepower motors down to just being able to run, for example, in the church here, you might have a common bathroom, maybe 5, 6 stalls in it, a couple of urinals, and maybe, for example, back in the day, the fan ran all the time. Well, now what we can do is we can tie the fan to the automated lighting switch. Doesn't need to run necessarily all the time. We can have it run when someone walks in, and we can have it run 5-10 minutes after they leave, just to clear the air circulation in that room. And based on load, let's say we can start to size that fan, depending on the size of the bathroom, or let's say, for example, a stadium restroom that might have anywhere from 5 people using it to 50 people using it at a time. We can now take that motor on a variable freak drive and we can really ramp it up and down based on load in that exhaust cycle. The ECM, electronically commutated motor, variable speed direct current. ECM 2.3 variable speed motor technology started coming out and can be compared to using a dimmer switch in lighting applications, meaning it is highly variable, making its precise performance ideal for a variety of advanced applications. So this is really becoming a standard boilerplate in a lot of your residential and getting into your commercial heating and cooling applications. Most manufacturers typically position an ECM motor as a premium product offering and use the motors in furnaces, air handlers, condensing units, and packaged products. The popularity of the ECM motor can be attributed to its performance, flexibility, and reliability. Well, how efficient are these new ECM DC motors? We had the privilege, one of our extreme green projects, we had a monitoring system on their house. We installed a solar thermal Bosch Badera system 4 years ago. We came back 2 years later, installed an MIM solar PV system. Came back a year after that and took out their old furnace, and we did an air sealing on the house. That new furnace that we put in, they had an old 80% atmospheric vented furnace, and we moved them to a 96% efficient furnace with a variable speed drive. Now, they had a large home. It was a Rambler stretched out on a fair-sized property. The problem they had was they had hot spots and cool spots throughout the house, always struggling with. The basement was always cooler, was a different temperature, felt different than the upstairs. And they ran their system all the time, just trying to move air through their house. And it cost them. Well, let's see how much it cost them. So what we have here in the green is the production of their solar system. Okay? This is an E-gauge energy monitoring system. We have on the bottom here the months of January, February, March, April. We're looking at their monthly consumption and their monthly production. On January 20th, we took out their old furnace that had a constant speed fan. Actually, they call it a multi-speed fan. It has a high, low, and a medium based on heating, cooling, and just running the fan cycle. Now, look at the difference here. It went from that day, this energy consumption, almost 1,000 watts, a kilowatt in energy savings just moving to this fan. Now, this is, bear in mind, this is just the electricity. The gas alone, from an 80% to a 96% modulating gas valve, was an amazing step in energy efficiency for this property. So another example, how efficient are these systems? How about 80% or greater when we talk about just the fan speed technologies? You think the utility company likes this? LEDs. How many people have installed any LEDs in their property? Good for you. Isn't it fun to watch the cost of these products start to drop? Probably not so when you first bought them a year ago, but it's amazing, these technologies, what's driving these changes. So I don't need to tell you too much about LEDs. Light emitting diode is one of today's most energy efficient and rapidly developing lighting technologies. Quality LED light bulbs last longer, are more durable, and offer comparable or better light quality than other types of lighting. Let's take a look real quick for an example and see what the difference is. We did a commercial LED lighting retrofit, and we happened to do a case study on it. And so what we have here is we have I believe this was a seven building condominium complex in South Minneapolis. And this building, we just went after the exterior lighting. So they made a $18,400 investment, was paid off in 4 years with a $3,600 annual savings, equal to $306 a month. The energy reduction, energy demand of 7.23 kilowatt via replacement of existing exterior lights. 8.7 with new LED lighting system, 1.4. Energy usage savings of 31,679 kilowatt hours. Existing usage of 38,000 reduced to 6,400 kilowatt hours. Now, while we thought the numbers were impressive, what was the most interesting comment that people made about this retrofit was they talked about, hey, we can now see the things in our parking lot. We can see the difference between a maroon car and a black car, because before they had high pressure sodiums, HPSs, and they couldn't tell. They called it the old mood lighting. They would talk about, before their energy retrofit, they had mood lighting, and they would have a conversation at night next to these lights, and they could barely tell the colors that people were wearing, or the colors of cars in their parking lot. So they were very excited about the bright white light that they were now getting. An example of some of these replacements, we were going from 150 watt HIDs to 20 watt fixtures. That is a huge savings. Huge. So that pretty much is the end of my presentation. There's 10 minutes left in the presentation for you guys to ask some questions. Think about these technologies, where the future is headed, how these technologies are being used. A lot of people ask me, well, hey, yes, there's a cost for these technologies. How can we afford these? Well, I think it's about commitment. I think it's about thinking about the next generation. I think it's a commitment more than just dollars. And I think also that when we look at it, when we look at the analytics, the energy savings come out in the long run, whether it's a 5-year payback or a 10-year payback. The facts are there. The numbers, the proof, the evidence, the numbers are there. That's what our company does, is we put that information out there. So questions?
I've heard that ground source heat pumps need a lot of power to run the loops, pump the water. What's the current thinking on that, and are they really that efficient and worth?
Good question. So our company, we are an IGBA certified heat pump, ground source heat pump installer. We looked at this and did a couple installations 5 years ago. Commercially, I did many systems. 2 big challenges with heat pumps. In a retrofit on a residential property, your duct system, the volume of air that you have to move, has to be almost twice the volume, because we're really talking about the airflow dynamics across a coil and how many BTUs of heating or how many BTUs of cooling we can get across the coil has to be a lot, which means we have to increase the size of the ductwork. Otherwise, we're going to hear the vents and the registers. We're going to hear that system running. What really was a turnoff to me was the engineering that I was seeing and the system being installed always had a backup heat strip element, resistant heat, for really cold days. And to me, that kind of started to just kind of defeat the purpose of, well, I've got this system that's supposed to do my heating, but it can only do it down to 10 degrees or 20 degrees, and now this electric resistant duct heater is making up the difference. Now, the pumps themselves, yes, in the old days used a lot of energy. The technologies that we're seeing coming out with the VLO pumps, variable speed pumps. So the variable speed pumps now run more often with less energy demand, and just like the DC motors, they're moving more BTUs at a much more energy efficient level. So the technology has changed on ground source heat pumps. It's a really hard argument when, for the cost of a ground source heat pump installation in the city, Minneapolis or St. Paul, when you could go to a 96% efficient furnace, and the cost of natural gas at what it's at, when you put the numbers out there, it's a hard comparison. It's a hard convince. Yes?
So this is kind of a comment and a challenge. So, you talk about the commitment and they're more expensive. But when you look at the largest users of energy, it's usually in lower income areas of the city, older housing, and they're the ones that are using the majority of energy relative to other people. I mean, if you have money, you can afford to have R50 walls and good windows and technology. So how do we bring that to the places that's really going to save us, and I mean all of us, the most energy? How do we do that?
Mm-hmm. Great question. So how do we do that? We do that through good public policy. What does good public policy look like? It looks like adapting and creating policies that become ordinances, that become code, that become requirements in any and all new construction. So in 2014, we had a huge changeover with all new construction. New requirements required that. There's a big push now with rental properties. The city of Minneapolis is doing a huge push with existing properties and structures, because there are people in those properties that want the opportunity to save money. They don't want a $200 heat bill every month in the winter. But they are in a system, maybe it's a rental property or maybe it's the property they could afford, they're in a system now that requires the property owner to make that financial commitment to make those changes. What I see happening is, and our company does a lot of TISH responses. So TISH is Truth in Housing Sales. Right now, whenever you sell a property or you have a rental property, it is the one and only opportunity that the city has to get into your property before you're allowed to sell it to make changes required to the property. And so I get TISH lists in front of me that can be 3-4 pages from rental properties. And it could be everything from plumbing issues to heating issues to venting issues. So I believe the answer, the solution to that is through the public policy that creates and adopts ordinances that can address the older building stock when there's a conversion of property ownership or a conversion of renters. That's really the only window we have. Unless you mandate these things, most rental property owners, not all of them, are going to decide to use their dollars in a different way.
Can I challenge on that? Because I'm in the process of helping a friend build going to be buying one of those Green Homes North houses.
Yep.
J. Eisenberg's the architect. And current code, the current code was fine, but when I ran the first numbers on current code, it would have hit a 55. And I'm of the philosophy that, 55 okay, so it's better than, but that doesn't, just because it's better doesn't mean it's good. And that's what current policy is that just because it's better doesn't mean it's good. So this house, the city is funding 30% of the funding for it. At code, only hit a 55.
Mm-hmm.
And so so we asked the architect to do above and beyond that, and he didn't know how to do it. So we're helping him do that on this house. It's only adding 10% to the cost of the house to bring it down to a 17.
And this was a new construction, correct?
Yeah, new construction.
So I'm very familiar with the Green Homes North program, and I was involved with that. I will tell you, the pushback that the developers had, the builders, when they took a look at their investment dollar per dollar in houses on a flip versus a new construction with the city's requirements, they walked away from the table.
I know, it's ridiculous because the house is going to pay for, these upgrades are going to pay for themselves in 5 years. And current code is not going to give us to 2030.
Correct. Now, one thing I'll say about code, you're absolutely right. Whenever we build to code, we're building to minimum standards. You can always go above and beyond code, but code establishes minimum standards. Until we have a larger voice or until we have stronger policies that changes code, and I tell you what, there's a lot of pushback when it comes to changing code. It's enormous. You have to take, step by step the changes as they come.
Right now, it's over the sprinkler requirements.
Absolutely. Yep, that got shot down. I'm amazed. So one of the things our company does also, we do energy audits. Per the 2014 Energy Code, which is now getting adopted in 2015, requires all new home construction to have an energy audit. And it's amazing to me, I had an intern come in from Augsburg, and we structured a marketing campaign to 300 building contractors. And I said, you know what? I bet you half of these people don't know what an energy audit is because they've been building new homes and tract homes for so long. I said they probably don't even know the new requirements or the compliance required to get to their certificate of occupancy. And we found that niche market, and we found that opportunity amongst 300 new home builders to say, hey, you've got a problem, and it's because you're probably not going to get your certificate of occupancy unless you have compliance and you have a blower door energy audit done on this new home. So it amazes to me, the point of the story is the fact that so many of these new home builders just, they throw their arms up in the air and they get stuck or they never heard of it. And there's a lot of education required on this. We need the BATC, we need so many apprenticeship programs and so many trade unions and other organizations to get on board. That's the one biggest challenge I would say As a contractor, I found, and I've gone through a 5-year apprenticeship program many years ago, I've found that the bureaucracies of the apprentice trade schools is that they generally run about 2 to 3 years behind in the technologies. The stuff that we're installing today, I can't get apprentices out of these schools. I can't get journeymen turning out that are familiar with any of this stuff. The way we get trained is directly from the manufacturers. Our staff, our field techs, the only way they can find this information is one-on-one with the manufacturer's certifications, their representatives, and the manufacturer training. So I do find it challenging. I find it frustrating that I've hired a lot of people out of the trade unions, put them in front of this technology, and they're just, oh, I don't know, they never taught us on this. So I have to educate people. I got about a couple minutes left for 2 more questions. Yes?
What is a mini split heat pump?
Mini split heat pump. You came late to the game. Mini split heat pump is a ductless heating and cooling unit that has an outdoor compressor condenser, has a refrigeration line set up to a remote head unit. That remote head unit has a blower wheel in it, and then it has a evaporator that does both heating and cooling. And so you might have, for example, the infamous story-and-a-half house in South Minneapolis or St. Paul that has 100-degree attic or 100-degree temperature in the summer, and my wife is freezing because it's 50 degrees in the winter, because none of these homes had the appropriate ductwork that was run up to the story-and-a-half or even up to the 2-story. So what happens is this is the solution. Instead of opening up the walls, opening up the ceilings, opening up the floor, running new sheet metal, this is the solution to have a zone heating and cooling, is to have a mini split air-to-air heat pump. And as was mentioned here before, this technology has been around for a decade. And we look at China, we look at the Middle East, they've been running heat pumps forever. One more question. Yes?
I was just going to say, great job, Dennis. It's been awesome. I was going to mention that the grid defection report that you referenced in there from the Rocky Mountain Institute, which is rmi.org, this morning, late last night, came out with a really amazing battery storage paper, big white paper. Highly recommend you go read it. It's probably 5 years in the future, but it really lays out the services that the utility gets, the homeowner gets, the grid gets, and
Is it the services or benefits?
Benefits.
Benefits.
Well, they consider it a service that you could rate off of, right?
Okay.
So they call it a service. But anyway, rmi.org, if you haven't read it, it's some really great stuff.
Awesome.
Let's get thoughts in the hand.